We're back on the morning show this Wednesday with our wise guy, Matt Sellin, physics professor from U of I, who's showing us inside TV. So you're watching us on TV, and we're also showing you inside TV.
It boggles the mind, doesn't it?
Yeah, it really does.
So we talked in the first segment about how the stuff that's inside the back of your TV, and you never want to take it apart because you can get electrocuted even if it's not plugged in. But if you look in the back of your TV, there's some very distinctive components here. I'll kind of turn this sideways. There's this glass tube that sticks out, and in fact, the picture tube itself is entirely made out of glass, and there's a vacuum inside it. And so you get a little electron beam that gets shot from the back of this tube toward the front of the screen where the phosphor is. Then you have to steer it around, because what happens is you need to basically move it from each little pixel, each little dot on your TV screen to the next little dot and light it up or not light it up, as the case may be.
Right.
And you have to do this very quickly. And so you have to steer the beam around, and the way you do this is with magnets.
Okay.
And so you make these electromagnets, this thing that's right here. If you break a TV, which we did here, you get this out of it. And so these coils actually are used to create a magnetic field which bends the electron beam so that it can see the entire screen, and it rasters back and forth. So the magnet is actually the key component of this whole thing. It shoots the beam back and forth and up and down. And you can tell that the magnet is a very important part of this, and I'm going to show you something now which you should never do at home.
Okay.
Because you can ruin your television.
We say that a lot in this segment. Okay.
Right. So either you can kill yourself or ruin something, so either way it's not so good. But if you can see that magnet is important, because we have a little TV set up right over here, and you can see us on it. And if I step on the side of this thing and I just take this magnet, which I have in my hand, and I just kind of bring it up close to this.
Oh my goodness.
It really distorts the picture. And in fact, if I hold the magnet close to the back here, the back of the TV, whoops. Okay, so you can really see that the magnet, even if I'm not very close to it, distorts the picture completely.
Now, I didn't know you should not have a magnet next to a television set, but I have heard this about the computer.
Right.
So same concept.
It's the same idea, and on your computer screen, quite often you'll have a little button that says degauss. Okay. And you push this button, and the screen goes doing and makes this funny sound, and then the picture's better. Your TVs don't usually have that, and what happens is inside a color TV, there's several of these electron guns. They're all going in unison, and they all light up different pixels to give you the different colors. And if you get anything messed up between the three, then the colors are all messed up. And so if you bring a magnet or a fridge magnet even near a color television, you'll see you can really wreck it pretty quick. So you never want to do that.
So is this the same now that the flat screen TVs are in and the plasma TVs? Because I remember the picture tube used to always go out in your TV.
Right.
Is that still?
They are the same, and so basically the TVs that have the picture tubes in them, they're always kind of thick.
Yeah.
Because you have to be able to have a long enough path for the electrons that you can steer them around. And it's very hard to engineer these things. The LCD and the plasma screens work in a completely different way, and I might discuss that either next week or the following week, because they're fascinating how that things work. Actually, they're actually much simpler.
But
in a sense.
Really, so similar concept, but a little simpler.
Right.
So talking about how you're watching us with electrons this morning in physics. Matt, thanks for being here and explaining it. Matt Sellin, our wise guy. If you have questions, you can get in touch with us via email or at wiseguy.net. We'll be back.